H comma K. Go ahead and give that a guess here. Can you tell me the vertex from this? It's okay if you can. I just trying to see where you're at as far as, what you remember from class. If this looks totally foreign to you, we can.
Is it 2, -5?
So the -5 is correct. The 2 it's actually opposite of the sign inside parentheses here. So the vertex is actually at
-2.
-2 comma -5. And so you want to put a dot there. There's the dot for -2, -5. And then the way that I like to show students how to graph this is to make a table X, Y. That vertex goes right in the middle, and then you need 2 points smaller and 2 points larger. Right. So for these other points, there's symmetry that you can use. You don't have to do them all. You just have to do either -1 or -3, and you're putting that in for X. And what I can't remember is if you're allowed to use a calculator or not. I think it's a calculator on this. So you have to do it by hand. So let's just try -1. It's 2 -1 plus 2 squared -5. And this is order of operations. So you have to add inside parentheses, then square, then multiply by 2, then subtract 5. Could you give that a try for us, please?
Yeah. Two squared is 4, right? I'm lost.
So -1 plus 2, what does that become?
1.
1. So it's 1 squared. What is 1 squared?
1.
1 times 1 is 1. 2 times 1,
2.
-5,
3.
-3. All right, so if you didn't write down everything here, that's a good place to start as far as like how to improve. Great to share your work. It's not really for me, it's just so that you can look back. That is the answer for -1. Now, it just so happens that because of symmetry, these are the same. Okay, and also by symmetry, the 0 and the -4 output will also be the same. So we're gonna try that now. We're gonna put 0 in for X. We'll do that here off to the right. Y equals 2, 0 plus 2 squared minus -5. I'd like you to try simplifying this for me, please.
Is it 3? I can't hear it. Can you hear me? Be quiet, Lucas. I can't hear it.
Oh, I apologize. I do that occasionally. I muted myself. Everything you did was correct. And I was just making the point, make sure you nice smooth curve here when you're graphing.
Uh,
That's about it. Okay. Domain. So let me know when you get caught up here, and then we can talk about all this other stuff. Graph really leads to all these things over here. Domain is always all real numbers for parabolas. Do you remember anything about the range, which is the y values here? Like
negative 2
what's the smallest y value? That's the x value.
or
Y
negative
value.
5.
Okay, -5. And then what's the largest y value?
Infinity.
Goes up forever, yeah. Now, infinities always get parentheses. The -5 gets a bracket because it's included. All right, now this increasing and decreasing, these are the x values of the vertex. Okay, so like the options are it's either increasing from -2 to infinity or -infinity to -2. And increasing means it's going up and to the right. Decreasing means it's going down and to the right. So it's increasing from -2 to infinity, decreasing from -infinity to -2. Any questions on that or thoughts?
No.
Okay, we should
What
do,
or
sorry.
what matters the x and y on the decreasing? Like, why does it matter if -2 is first or second?
Yeah, it does. It does. This means all the numbers to the right of -2. So like there's a split at -2. -2 is this dividing line. Like, I don't know if you've ever done any hiking, but think of decreasing as like walking downhill and increasing as walking uphill.
Okay.
If you don't hike, I mean, just think about, I don't know, driving or so anything where, one way you're going kind of down, one way you're going up. There's some reference.
All right.
Okay.
Okay.
Like I mentioned before, there's no like extra, no like double up problems here. So we got to just do them one at a time. And number three is number three. So absolute values are kind of like, they're kind of like V quadratics. They are V-shaped. V-shape. Maybe make that a little bit more of a V. Okay. This one's already in the right form, this standard form. It does have a vertex point, which is just like the quadratic. It has to do with this number in here and then this number out here. Do you want to give that a try and let me know what you think the vertex is for this?
Okay. Is it 1, -1?
Yes, perfect. All right, so that's the first point to draw, 1, -1, right there. And then as far as the table goes, I think we talked about this one because there's a small issue with fractions, and you really want to avoid graphing, really want to avoid working with fractions if you can. So in the table here, we have 1, -1 right in the middle. And let's just put in, let's just go larger here. I'm just gonna put 2 in. And so let's work that out here. Y equals -1/2 absolute value 2 minus 1 minus 1. So you'd start here inside parentheses. 2 minus 1 is 1. Absolute value of 1 is 1. But then you've got -1/2 times 1, which is a fraction, and that's bad. Like you really don't want that. I don't know if you guys talked about that in class, but that suggests, okay, maybe 2 isn't the right number. Let's go up one more. Let's go 3. Now, 3 minus 1 is 2. Absolute value of 2 is
2.
2. -1/2 times 2 all of a sudden is a nice number. It becomes -1. -1 minus 1 is -2, like that. Now, maybe you like fractions. Maybe you're the exception. I recommend not getting involved with fractions if you don't have to. Okay. So I normally say go 2 larger and 2 smaller, but here we went +2 to the right. So we need to go backwards -2. So like your points should be equidistant away. So 3 is 2 away from 1, -1 is 2 away from 1. That's how you get the symmetry here. Any thoughts on what I've done here or anything you feel like you don't understand or isn't clear?
No,
Okay. Good. If it's ever unclear, just say, hey, Matthew, I don't understand because I can't read your body language to know if it's like, yeah, I get it or you don't get it. Now we're going to do the same thing here. We're going to go, because we went 2 away, we're going to go another 2 away, which is to 5. All right. So I want you to simplify this thing on the right here. So 5 minus 1, absolute value of that, -1/2 times that, -1. Should be a nice number.
is it 1?
It is not 1 because they're both negative. Like these is going to go down here. So it should be -1/2 times 4 minus 1.
Is it -3?
Yes, that is correct. So then when we're going the other direction now on the table, like we gotta go the other direction here, we gotta subtract 2. So that's -3, and that goes with the -3. All right, so that gives us enough points to be able to graph this. We're gonna you use the symmetry here, like you do the vertex first, which you already have right there. Boom, we got it. And then 3, -2. And then by symmetry, we got this other point over here, -1, -2, and then 5, -3. And if we go the other direction, and see how this just graphs so much nicer, except I graphed these both in the wrong spot. There we go. You can see it's got this V shape. It's got to have a V shape. All right, so whenever you're ready, we can go through the domain and range.
Okay.
Does that mean you're ready for this?
Yes.
Okay,
Sorry.
excellent, excellent. Okay, just making sure. I'll figure that out as more time passes here. Domain is -infinity to infinity. You'll notice that most of them are this. A few exceptions are square root, some rational. The range is the y values. So you got to think about the smallest y value, basically like how far down does this go?
-1.
If you're saying -1 is the smallest y value, there's no y value smaller than -1 y values. Like if you just look at this point here, it's got a y value of -3, which is smaller than -1. That's the largest y value,
So -3.
but it keeps going.
-infinity.
Yes, yes. So it goes all the way down to -infinity, and it goes up to the largest y value. That's where
So
that's
negative.
right. Yeah, and you might use words like min max, bottom to top. Something like that. The increasing and decreasing, the x value is kind of that breakpoint. And you can see here there's this breakpoint is right in the middle. Right in the middle. And I made the reference to hiking. If it's increasing, you're going uphill. If you're decreasing, you're going downhill. And it's really similar to the previous one, meaning you use that x value as the breakpoint. So one of the answers is -infinity. One of them is -infinity to 1. One of them is 1 to infinity. So which is increasing, which is decreasing?
Um. Is increasing -infinity 1?
Increasing is -infinity to 1, and then decreasing is from 1 to infinity. Any questions, thoughts, follow up on any of those before we move on to,
No.
okay. Did we do 4?
Huh?
Have we done 4 yet?
I don't think so. I don't have it done.
Okay, let's do 4 then. Okay, so yet another parent function. This one is a cubic. And it doesn't have a vertex, but it has kind of the same feature where you want to know this equivalent to a vertex, but it's not called a vertex. It's like this point that's related to the part inside parentheses and outside here. It is something on the graph that you'll learn maybe if you take calculus someday. But can you give me that point, like the equivalent of the vertex?
Um, is it -2, -5?
Okay, good. So what that point is it's this place where the graph switches from like this to like this, or like this to like this, and we'll see that based on the other things that we do here. So the next thing is to build a table, and that point goes right in the middle. So you'll see I'm fairly consistent with how I show this. -2, -5. This time you don't get any symmetry benefit. So you do have to actually try these values. They're not the same, which I know is it's like, a little more work to do, but that is required here. So let's do the -1 first. Y equals -1 plus 2 to the power of 3 minus 5. So you have to work the part inside parentheses, then cube it, then subtract 5.
Is it -4?
It is -4, yes. And like I said, unfortunately, you don't get the symmetry benefit here. So when you do -3 plus 2 cubed minus 5, it ends up being -1 cubed, which is -1, minus 5 equals minus 6, like that. You'll have to talk to your instructor to find out how many points you need to graph. 5 is kind of a standard. Like I said, kind of, couldn't say for sure. Um, but I'd like you to try these last 2 points. Um, go ahead and work those out for me and let me know what you come up with. And I'll be right back with you. All right. So if you have any of those numbers, let me know.
Is it -13 and -3?
This one is -13. This one, though, is 2 cubed, which is 8, minus 5, which is positive 3.
Oh.
All right, now we're going to graph these points. There is no symmetry to take advantage of, so just be very careful here. -1, -4, 0, 3. And you can do the same on your graph, -3, -6. And then that last one, and maybe talk to your instructor. I mean, you can kind of say, well, it's kind of down there. It's got this kind of an S shape to it. If you don't agree that's an S, I get it. It's got some sort of a curvature though to it. Some instructors are okay with just the 3 points. Some want all 5. All right, let's go to domain. What do you think the domain is for this one?
Negative infinity and to infinity.
Exactly. Yeah. The range is the y values. It's like, how far down does this go? Well, it goes down forever and it goes up forever. So it is also -infinity to infinity. And then increasing is where it's going up and to the right. Do you notice that it is always going up and to the right?
Yes.
So the answer here is kind of this. We were in a calculus course, we would maybe have an issue with this, but probably is okay here. Of course. Decreasing,
Is never right.
none or never. Yeah, whatever your instructor uses, that's the language you want to use. Okay, did we do 5 or not?
We did do 5.
Did 5. Okay, so we'll go to 6. Right. Did I send you a link to all the parent functions that you may be asked to know? Like a picture?
You did in the chat the last time, but I don't have it open, so.
Okay. So this is kind of related to the last one. So let me just draw this here. So a cube looks like this. A cube root looks like this. And they're very much related. Like you can kind of see like they're turned sideways, kind of. I mean, not perfect, but they've got kind of the same shape. And that's how you remember these when you learn them the first time. You got to draw comparisons to other ones. Okay. So this one, again, doesn't have a vertex. It has like a center point. It's not really a vertex. It's really a center. Can you give me that center? It is the same way we've been doing it, where this part is in parentheses.
-1, 2.
It is -1, comma 2. Good. And that does go right in the middle of your table. One of the problems with this one though is you cannot take the cube root of very many things. You can take the cube root of only a few things. You can take the cube root of 0. The cube root of 1 is 1. The cube root of -1 is -1. The cube root of 8 is 2, and the cube root of -8 is -2. Now, the reason this one works is because when you put -1 in for x, you get -1 plus 1, cube root of that, plus 2. This becomes the cube root of 0 plus 2 is 2. Cube root of 0 is 0. 0 plus 2 is 2. Is that okay? Clear?
Yeah.
All right. Now, what we want next is really, so like what you have here in the middle is the equivalent of like the cube root of 0. You want your next number here for x to give you the equivalent of the cube root of 1. So you have to sort of say, well, how do I get 1 from x plus 1? What would x have to be so that x plus 1 is 1?
0.
0, yeah. So it's the cube root of 0 plus 1 plus 2. You see this on standardized tests as well, where you have to take the cube root of a number you can actually take the cube root of, which aren't that many, or the square root of a number that you can take the square root of. So this is the cube root of 1 plus 2. Cube root of 1 is 1 plus 2 is 3. So let's keep going in the positive direction. What number should x be so that x plus 1 is 8?
7.
Yes, 7. So the cube root of 7 plus 1 is the cube root of 8, which is 2. 2 plus 2 is 4. Sometimes going backwards is the more difficult direction, but we'll try. We need to figure out what number goes in here for x such that x plus 1 becomes -1. So what is the x value such that when you add 1 to it, you get to -1?
-2.
-2, very good. So this is the cube root, -2 plus 1 plus 2. The cube root of -1 becomes -1. -1 plus 2 is 1. All right, then the next one here, we want to get to -8. That's -9. Can you tell me what value goes in here for y, please?
For what again?
So I'm giving you the x value this time. I'm just going to tell you it's -9. I'm just asking to simplify, putting -9 in for x plus 1, cube root of that plus 2. You should also see a pattern here with these y values, meaning like the answer's not out of line with what you already see.
Is it -1? Or 0?
It's 0, yeah. Yeah, there you go. All right, so these are the points we should graph. We've already graphed the 1. Get those down, and then we'll put them on the graph here and answer all the other stuff that you see in there.
I already wrote.
Excellent. All right, I didn't write them all down. -2, 1. What was the last one there? 7, 4. Sorry for all the scrolling. Make sure you put those arrows on the end. Instructors do look for that. They do great for that.
Okay.
Now we can talk about domain and range. What do you think the domain is on this?
Um, all real numbers.
All real numbers, minus infinity to infinity. Range is a little bit tougher because you may not see that or even believe that it goes down forever. Looks like it just goes left forever. It does actually go down forever. It just takes a really long time to get there. Same thing on the right here. It goes up forever, even though it doesn't look like it because it goes really slowly. But it goes more to the right than it goes up. But the idea of infinity is that it's literally all the way, as far as you can imagine going. So you can forever go out. It eventually does go up. It just doesn't look like it. What would you say for increasing on this one?
Um, is it 3 infinity? No.
So you're trying to break it up right here at 3. Remember, these are the x values. Now let's just say you're trying to do it because it was here where y is 3. But if you're hiking or whatever analogy you want to draw, like, are you going uphill here? Uphill here? Where are you going uphill?
Yeah.
And the answer is everywhere. So even though it's like not as uphill as the previous one, it's still uphill everywhere. Maybe hiking's a bad example because this one's more steep. And you're like, yeah, it's really steep. That's uphill. But even if it's just gradually uphill, it's still uphill. Decreasing is none because there's no downhill. And when you think of uphill and downhill, you're always going to the right. We read left to right. We look at things left to right. Maybe if you're left-handed, you could argue that that's odd, but for the rest of us, that's considered normal. All right. Do you have all this down for today? Excellent. Okay. So again, those parent functions are key. We really would look, and your book probably has one. Make some note cards for that. Domain and range, maybe some flashcards for that or a Quizlet, and definitely this increasing and decreasing, some note cards for that. It's going to keep coming up in this course.
Okay.
Something you can quickly look at. I'm sure there's a Quizlet out there already on this you need to review. All right, well, we'll go ahead and stop here for today.